video, we will learn to find the eigenvalues and eigenvectors of a matrix. So to find the eigenvalues and eigenvectors of a matrix means we want to find the pairs of non-zero vectors v and scalar values lambda such that when we apply the matrix A to this vector, we simply return a scalar multiple of the vector. In this case, we call v the eigenvector corresponding to the eigenvalue lambda. Now, in order to find this, we can simply rearrange this expression. So I move the lambda v to the left and then factorize out the v from the right, and I should get the following expression. Now, in order for v to be a non-zero vector, that's the same as saying that the matrix A minus lambda I must be singular, and so it must have a determinant of 0. And so this means that if I want to find the eigenvalues of a matrix, all I need to do is actually find the values for lambda so that the determinant of A minus lambda I is 0. And that v is any vector that lies in the kernel, because we want A minus lambda I multiplied by v to be the 0 vector. So an example is to find all the eigenvalues and eigenvectors of this matrix A. So first we want to find A minus lambda I, because we said that we can find the eigenvalues by simply setting the determinant of A minus lambda I to be 0. So we do A minus lambda I, where I is the 2x2 identity matrix. So it has 1 on the diagonals, and we simply multiply each of those by lambda. So next we want to set this determinant to 0. So I find the determinant of the matrix that we just worked out, so I multiply together the diagonal terms, and I subtract the product of the two off-diagonal terms. And so we end up having lambda squared minus 5 lambda plus 6. So I want to set this determinant to 0, and then we can simply solve the quadratic equation and obtain lambda is equal to 2 and 3. So the eigenvalues of this matrix are 2 and 3. And so next we want to find the eigenvectors of the matrix. So for the eigenvalue 2, the eigenspace for this eigenvalue, which means the set of all eigenvectors with the eigenvalue 2, is simply the kernel of A minus 2i. So if we have a vector which we'll just call v with components xy, if it lies in the kernel, what we're saying is that when I apply A minus 2i to this vector, it gives me the 0 vector. And so here we've evaluated A minus 2i to be this matrix negative 1, 2, negative 1, 2. So if I apply this matrix to V, we should get the 0 vector. But this is simply saying, if I expand out this matrix, I will get a single equation, which is negative x plus 2y equals to 0, or x equals to 2y. So this is saying that any vector I have, where the first component is 2 times of the second component, it would lie in the eigenspace. So one example of this would be the vector 2, 1. Its first component is 2 times of its second component. And so this vector lies in the eigenspace, and so it is an eigenvector with an eigenvalue of 2. So we can very similarly do the same process for the eigenvalue 3, and you will show that v equals to 1, 1 is one of the eigenvectors for the eigenvalue 3.